Welcome back, everyone. We're at the last lesson or the last lecture or whatever you want to call these for Chapter 12, Statistics and Math 120. This is it, folks. So we're going to do a number of things. First of all, we're going to make a scatter plot for a table of data items. And if you haven't done that before, most of you probably haven't, I don't do it that much either, but it's easy, but it does have several steps. Just follow them. Next, you want to also be able to interpret what you see there. That's where it really gets interesting and useful. Next, compute the correlation coefficient. If you actually tried to calculate not just the mean, but the standard deviation, you probably didn't enjoy that. It takes a lot of different steps. Well, that's nothing compared to the correlation coefficient. That thing is a monster. But the TI-84 is definitely your friend on this one. We'll make it easy. The hard part actually is just putting the numbers in. And everything from there is easy. We'll find the equation of the regression line. Don't worry about what that is, but you're just going to find it anyway, and that's pretty easy too. You might want to write down some of these steps. And you want to use the correlation coefficient to decide whether there's a correlation, not causation, not one causing the other, just a correlation. That means there's a connection of some kind between, say, the x's and the y's. All right, let's get started with a scatter plot. What's it look like? Well, we're going to see some better ones, but for example, if this is your graph, maybe your plot will look something like this. And you can look at it and say, hey, I see a little bit of a pattern here. I think as I go from left to right, the points are going upward. That's possible. Other things are possible as well. But visually, your mind can find out things that you can't with just throwing numbers around. We're going to see whether two quantities are related. So correlation is what that means. Are they related? Co-related. See if there's a clear relationship between them. Find out what it is, how strong that correlation is, and what direction is it. Is it positive? Negative? We'll find out. So how do you get the scatter plot? Aha! Most of you haven't done this before. Now you'll be able to do that. We've already talked about putting numbers into lists. Well, that's the first thing you do. You go to Stat, Edit, and fill up list 1 and list 2 with the two variables, say like x's and y's. All you have to do is put it in. Second, once you've got those numbers in, you're going to the second key, then the y equals key above it, and that takes you to, if you look carefully, it's called stat plot. The first thing you need to do is turn on one of the plots. Otherwise, you'll hit a key to see something and nothing's going to show up. So second, y equals gets you to stat plot. Now once you get there, you want to make sure that plot 1 is turned on. And by the way, although this is likely not to be true, you want to make sure the other plots are turned off. So take a quick look, make sure plot 1 is on and the other ones are off. All you have to do is hit 1 or enter and you'll be right there. Set the type of graph to the first option. Now, if you look real carefully, the first option looks something like that. And it's supposed to represent a scatter plot. Anyway, it's the first one. That's all you need to know. Next, you want to tell it that the X list is in list L1. The Y list is in L2 because that's where you put them. Next. Oops, I forgot something here. Next, what you're going to do is hit the graph key. And on your calculator, that graph key is up about there on your calculator. Now, if you hit that and you don't see any points, that could be a huge disappointment, but all is not lost. Hit the zoom key. So you're asking, where is the zoom key? Well, the zoom key happens to be in the middle, near the top, somewhere up around here. Here's the graph key here, the y equals key is over here, and our zoom key is in the middle. Once you've hit that, you're going to get a menu. You might even memorize this, but zoom stat is what you want. Just hit the number 9, and that should put you in good shape. And hit graph again, and you should see a picture. Because what this does, it looks at your data and says, how can we show all of those points at one time? And there you go. You'll get a good picture of the data, and you'll know whether the points are going up or down or straight, whatever they're doing. So here's a picture of some data we could have. Notice we've got about 10 or so points here. You can see as you go from left to right, they start going downward. The y value is going downward. So there's a downward trend. So your eyes and brain have already put this together. Now there's some exceptions, but pretty much as you go from left to right, they're going downward. So if you look at what the X and the Y represents, this represents how many years of education. So as you're scanning from left to right, you're looking at dots that represent people that have more education than the ones do on the left. And as you go there, the Y values that represent measures of prejudice, according to some tests, they get lower and lower the higher the education is, in general. Now, you can't tell if there's a correlation between education and prejudice, but it does look as though there is a pattern. That's all we're looking for. Causal, you can't say. That correlation, even if it exists, could be a coincidence. There's one famous example that I read about years ago, and it found the correlation between teachers, pay, and alcohol sales in a particular county. As the teachers' pay went up, alcohol sales went up. So you might say, okay, there's a correlation there, but does it mean teachers' pay make the alcohol sales go up? Probably a coincidence. So education involves classrooms with a variety or lots of different kinds of people. Increased exposure to diversity might be the underlying cause in this example from that picture. So education might make people look at new ideas and cause them to be less prejudiced. You'd have to do a lot more research on that to find out if there's a connection at all. Next, so you've got a picture from your scatter plot, and maybe it looks like that, and you'd like to make a prediction. You'd like to say, what if I have an x value here? Let's say the x value is a 6. What would I expect from the y value over here? Well, the regression line is what enables us to fit a model. This regression line will be a model for connecting the x values and the y values. The regression line is the one that best fits. You might hear this phrase, a best fit line, because that calculator or whatever you use, Excel perhaps, is going to look at all those dots and find the best line that tends to go in the same direction with the least amount of disparity. Now that correlation coefficient, that's what's going to tell us how connected those are, how well they fit the model. R is our correlation coefficient. It measures the strength and direction of the relationship, all in one number. They're positively correlated. I made this green, so it's sort of a positive thing. If they tend to increase or decrease together, in other words, are they going up like this? That would be positive correlation. Negative correlation means they tend to go down like this, in general. So, correlation coefficients. So, first of all, suppose we have a positive correlation. If those points are all exactly on that regression line, then it's a perfect positive correlation, if they all fit on the line. If it's going down and all the points are exactly on the line, it's a perfect negative correlation. Remember the first one? Looks like this, where all the points are on that line. In the second one, it's going down and all the points are on that line. Now, how about the numbers? What does that R value actually tell you? This is the correlation coefficient. If it's a perfect positive correlation, that means it goes up to the right. Notice that that regression line fits it to a T. That's if it's an R value of 1, positive 1. If it's not quite 1, but maybe 0.8, that's still pretty good. If we draw our regression line, the points aren't too far away. That's a strong positive correlation. If they're a little bit further away, but we've still got a regression line, but the differences are a little bit more, a little bit stronger or bigger than in the previous one, like a 0.3. It's a moderate to weak positive correlation. Positive because it's going up to the right. And last of all, if they're spread out all over the place, R value anywhere really close to 0, that means there's no correlation at all. Next, we'll take a look at a negative correlation. If you look at this next one, picture E, the trend is downward, but the points are tending to be further away from the line. So if it's a negative, that means it's going downward, negative correlation, but it's only a 0.3 negative, then it's a moderate to weak negative correlation. Correlation is negative, but not very strong. If the points are closer to the regression line that we find, we get an R value that looks something like this perhaps. It's negative, but 0.8 is fairly close to a 1. And last of all, here's a perfect negative one where all those points fall on the same line. So those are 7 examples that you ought to know. Next. All right. Now we're going to grab our TI-84 and we're going to do some real work. First of all, we're going to take a look at this. And notice we've got X values on one line, the corresponding Y values on the line below it. When you're putting these in the calculator, for example, not only do you have to make sure that all of these go in L1, for example, L1, you have to make sure these are matched up. This 12 and this 1 are a pair. This 5 and this 7 are a pair. And don't mix them up. Don't put the 7 here and the 5 there. They have to go exactly where they show here. Excuse me. So you're going to put those in. And you're going to make sure, you're going to verify those numbers. Because all those numbers have to be right and they have to be matched up, or everything will be for naught. Now, let's get that calculator to work for you. Hit Stat again, go to Calculate. Your calculator is going to do an immense amount of work and you won't realize it because it does it so quickly. So you go to Stat, move the cursor over to the Calculate menu like you did before to get the mean and standard deviation. But this time, choose the 4th option. This is short for linear regression. Now, if you've got a sharp eye, you'll notice there's a second one. But I stick with number 4 because this resembles what we did in algebra, both in this class and in previous algebra classes you may have had. So I stick with number 4. Now, once you hit that number 4, you're going to get your own menu. At the top, it says linreg AX plus B, because that's the kind of regression you're going to be doing, the kind of calculations you're going to be doing. You need to tell where the x's are, so you put L1 there. If L1 isn't there, you can hit second 2, and you'll put an L1 there. Oops, sorry. Second 1. Got carried away with the 2's. For the Y list, put an L2 there. If it isn't already there, second 2, we'll put the L2 there. Third, the frequency list. Either clear that out or put a 1 there, and you'll be fine. You don't want L3 or anything else there. Last line, store regression equation. Now you don't have to put something there, but if you're going to use this answer for any work, this is a big help, because this will actually write the equation for you. Not on your paper, but it will on the screen. So on the next screen, the next page, I'm going to show you how to get that RY1 or Y sub 1 there. There wasn't room on the screen. Okay, so you've got L1 there, L2 there. How do you get that Y sub 1 in this spot? This is how you do it. Hit the vars key. That's over on the left-hand side, somewhere around the middle. Move your cursor over to Y bars. I think that's the second column. When you get over to Y bars, you'll see a new menu. Just pick number 1 and just hit enter for a function because you're working with functions. Once you hit that, you've got a lot of y's to choose from. Y sub 1, y sub 2, y sub 3, and so on. All you care about is this first one. That's all you need to use. So just hit 1 on the next screen and you'll be in business. As soon as you hit that 1, that store regression equation line is going to be pasted in for you. And what you will see will be this y sub 1 here where you didn't have anything at all. Once you hit that, go down to the calculate line, hit enter, and the calculator is going to really go to business. Now what do you see once it's finished? And it's going to take less than a second, don't worry. First of all, on the first line, it tells you which linear regression you're doing, because there's several kinds of regression you can do. This is a y equals ax plus b type. On the next line, it's going to tell you that if this is what you want, this is the a value that you just got from your linear regression work, or the calculator's work, really. This is the b value that would go in here, just like the a value goes here. And there's your equation. And you can write it down using that a and that b. Now, if you see something like 11.6, 2, 4, 5, 7, 8, 6, 4, 3, and so on, you might want to just slip that down to 11.62. Don't worry about all those other digits. They probably are not significant. So you can reduce the number of digits you're going to use for A and for B. Write down your equation, you're in business. You also get some other things too. Now this that R I was talking about earlier, that's the correlation coefficient. That's one of the 2 reasons you use this linear regression. Now there is something called R squared. We won't be talking about that. That's called the coefficient of variation, and it gives you an idea of how good a model this is going to be. The closer this R squared is to a 1, the better it is. So if you get a result of 0.95 for this, that's a pretty good one. You might want to keep that model. If instead you get 0.03, you might throw the model away and say, let's try something else. All right, so using those numbers in that table that I showed you back here on the bottom, this one, we can get this result if you've been working along or playing along with us. That's what you should get. And I put all the digits in just so you could compare it. Also, there's the correlation coefficient. We can tell 2 things from that. This goes way back several slides. First of all, this thing is close to 1. It's not too far away. So it's going to be a strong correlation. And first, also notice this is a positive. So it's a strong positive correlation just from that one number. Positive means that line is going up. A negative would mean it's going down. And the closer it is to 1 or -1, the stronger the correlation is. Oops. So there's the equation of your regression line. Cut off some of those extra decimals if you like. Keep about to the hundredths place and you'll be fine. And last of all, we can take the absolute value of that correlation coefficient, as I mentioned. Just look at this part of it. how close is that to 1? Since that's fairly close to 1, then you've got a pretty good correlation. The negative means it's going downward. The 0.82 says it's a strong one. Well, that's it, folks. We just finished a lot. And once you get familiar with this and feel comfortable with it, you're just about finished with chapter 12 and you're ready to go on to the review for the final exam and get ready to go. Well, that's it for now. I'll see you in class. Take care. Bye-bye.